So what is induction? Induction is a way to prove some statement is true for every choice of some variable n. So in this case, I've got an equation here, and this equation states that the sum of all integers from 1 to n is equal to n times n plus 1 on 2. So if I wanted to prove this formula is true, I guess I could sub in n equals 1, n equals 2, n equals 3, and check that it works. But if I wanted to try all numbers, I'd be here all day, right? And that won't do. I can't try infinitely many options. I'm going to need some sort of methodical way to check that this formula is true. So we can use a principle of induction. So if I call this entire statement here P of n, what I really want to prove is I want to prove for all n, P of n is true. Okay, that's what I want to prove. So here's the rule for induction, written out formally. We prove P of 1, or sometimes P of 0. So in this case, our base case is 1. So we want to prove P of 1. And we want to show for all n, P of n implies P of n plus 1. Therefore, for all n, P of n. So how does this work? I'll argue by analogy. Suppose I have a collection of dominoes, 1, 2, 3, etc. A whole bunch of dominoes stacked up in a row, and I want to prove all the dominoes fall over. If I can prove two statements, first statement being the first domino falls, so if I can prove the first one falls over, and I can also prove, if I can prove that if the nth one falls, so if the nth domino falls, then it knocks over its neighbor. So the n plus 1th domino falls. Okay, if I can prove these two statements, I can logically conclude that all the dominoes fall over. So this is basically how induction works. Proving that the first domino falls, that's usually called the base case. And proving that if some domino falls, then it takes its neighbor with it, that's usually called the step case. Okay? So they correspond to the base case here and the step case here in the definition of induction. So when we want to prove some statement by induction, we have to prove it's true for the base case, which is usually 1, sometimes 0. And we have to prove it for the step case. To prove it for the step case, we need to prove for every n, P of n implies P of n plus 1. How do we prove an implication? We assume the left-hand side, and we derive the right-hand side. So we assume the left is true for some n, and then prove the right-hand side is true. So prove the statement is still true for n plus 1. Okay? So let's do that with this formula here. So let's formally prove this formula works. Okay? So the first thing to do is prove it for the base case. I need to prove this formula works for n equals 1. And that's usually simple as just plugging in n equals 1 and verifying both sides are the same. So I'm going to write LHS means left-hand side. The left-hand side is equal to the sum of all the numbers from 1 to 1, which is just 1. The right-hand side, if we insert n equals 1, we have 1, 1 plus 1, 2. 2 on 2 is 1, so they cancel, so we get 1. So left-hand side equals right-hand side. So therefore the formula is true for the base case. Okay? For the step case, we assume the formula is true for some value k. So assume true for n equals k. Okay? And you can't make any assumptions about k. K is going to be arbitrary because I want to show that if any domino falls, it takes its neighbor with it. So assume true for n equals k. K is arbitrary. So what is it I'm assuming? I'm assuming that 1 plus 2 plus blah 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 plus k is equal to k plus 1 on 2. So I'm assuming this. This assumption is usually called the inductive hypothesis. Okay? And I want to use this statement to prove it's true for k plus 1. So I want to prove for n equals k plus 1. So I want to prove that 1 plus 2 plus blah 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 plus k plus 1 is equal to k plus 1, k plus 2, all on 2. Okay, that's my goal. So what can I do? Well, I notice if I look at the left-hand side, this section here looks exactly like this section here. So I can use my inductive hypothesis to rewrite this. So the left-hand side, it's going to be 1 plus 2 plus blah 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 plus k plus 1, which is the same as replacing this section here with the inductive hypothesis. It's going to be k plus 1 on 2 plus this term here, k plus 1, okay, which we can rearrange to be k plus 1 plus 2k plus 1 on 2. Okay, so that's what the left-hand side is equal to. Let's have a look at the right-hand side for a moment. So the right-hand side is k plus 1, k plus 2 on 2. So if we expand this term out, we get, what do we get? We get k squared plus 2k plus 1k, so plus 3k plus 2. Okay, and so if I expand out the left-hand side, so you want to sort of like mess with both sides and sort of look identical. So expand this out, k squared plus k plus 2k plus 2 all on 2. And put the two k's together, k squared plus 3k plus 2 all on 2. Oh, hooray, these terms match. So therefore the left-hand side equals the right-hand side. I've proven it for the base case n equals 1. I've proved it for the step case by assuming it's true for some k, proving it's true for k plus 1. Therefore, statement holds, or the statement is true for all n. So therefore, we've proven this formula is true for any choice of n. Okay? So that's how induction works.